Experts are detecting red tide blooms along some of our southern beaches. ABC Action News reporter Casey Albritton tonight with what you need to know and what you should do if you encounter it.
Let's start with something you can actually see and smell if you head down to the Texas Gulf Coast right now. The water's turning reddish-brown and something just feels off. That's not just dirty water, that's red tide, a type of harmful algae bloom that's not only toxic to marine life, but can also cause breathing problems for people near the shore. You've probably heard of red tide before. It happens when certain algae species grow out of control, usually because the water is warm and full of nutrients, mainly from fertilizers and agricultural runoff. The bloom looks dramatic, sure, but the real problem starts after the algae dies. As it decays, it sucks the oxygen out of the water, leaving huge zones where fish and other sea life literally can't breathe. These areas are called dead zones. And while they've been showing up in the Gulf for years, scientists are seeing something new in 2025. The dead zones are getting way worse. They're growing bigger, they're lasting longer, and they're moving closer to shore. Recent data from underwater gliders and satellite imaging shows that these low oxygen patches are now covering more than 10,000 square kilometers. That's not just a small area where fish can't survive. This is an entire region of the Gulf that's becoming a no-go zone for marine life. And the effects are showing up fast. Massive fish kills have been reported along the Texas coast. We're talking thousands of dead fish, shrimp, and even crabs washing up on beaches. Oyster beds, critical for both the ecosystem and the economy, are being wiped out. Some fishing zones are basically empty now. This isn't just bad for nature, it's bad for people. If this keeps up, the damage to Texas's billion-dollar seafood and tourism industries could be devastating. Fewer fish means fewer jobs. No oysters means fewer restaurants. And dead, smelly beaches? Not exactly great for vacation. So what's behind this spike? It's a mix of things. Climate change heating up the ocean, heavy fertilizer use, and shifting ocean currents all working together to create a perfect storm. Some scientists are experimenting with solutions like river buffer zones and underwater oxygenation, but honestly, those are band-aids. To really fix this, we'd need major changes in how we farm, how we manage water, and how we deal with climate change. For now, the Gulf is warning us, and if we don't start listening, it won't just be marine life that pays the price. Something strange is happening under the Gulf near Corpus Christi, and it's not small. In late 2024, scientists running seismic scans off the Texas coast picked up something they didn't expect: giant cracks stretching across the seafloor. And we're not talking about tiny fractures here. These are massive, miles-long gashes opening up beneath the ocean. The cracks are growing, some are widening, and they're not random. Sonar scans show they form an interconnected web across dozens of square miles. That's a huge red flag. Why does it matter? Because these cracks are way too close to some very important infrastructure. We're talking about oil pipelines, offshore drilling platforms, and storage units. Basically, the backbone of Texas's energy industry. If those cracks shift suddenly, it could snap pipelines, damage rigs, or even trigger a blowout. That would be an environmental and economic nightmare. And here's the scary part. The ground down there isn't exactly solid. It's made up of soft clay and silt, stuff that tends to slump and shift when disturbed. Some parts of the seabed have already dropped by several feet just over the past few months. Remote-operated vehicles sent down to investigate have captured eerie footage of sediment clouds rising from the cracks. That means these aren't old, stable features, they're still active, they're moving. Slowly, but constantly. Scientists are starting to worry this might be part of a bigger problem. These shallow cracks could eventually connect with deeper fault lines that run along the Texas coastline. And if that happens, we could be looking at major undersea land shifts, possibly even quakes or seabed collapses. To get ahead of it, emergency response teams are working with offshore companies to install early warning systems, pressure sensors, and seismic monitors that can detect shifts before something catastrophic happens. But let's be real, no sensor system is perfect, and this region isn't used to dealing with geological instability like this. If these cracks keep growing, or worse, if they trigger a sudden collapse, millions of people and billions of dollars in infrastructure could be at serious risk. Bottom line, something is shifting under Corpus Christi, and while it's happening out of sight, it might not stay out of mind for long. Here's something most people don't realize. There's gas leaking out of the Gulf of Mexico, not from oil rigs, but from the seafloor itself. And it's not just any gas, it's methane. Recently, scientists mapping the Gulf's continental shelf found hundreds of methane vents bubbling up from the ocean floor. Imagine a field of tiny underwater volcanoes. But instead of lava, they're releasing gas into the water. Some of these plumes are huge, rising hundreds of feet. They're visible on sonar and, in calm water, even from the surface. So what's causing it? Most of this gas comes from something called methane hydrates. These are frozen pockets of methane trapped in the sediment under the seafloor. They're sometimes called fire ice because they stay solid under pressure and cold. But if the temperature rises or pressure shifts, they start to break apart and release gas. Guess what's happening now? Yep, warming oceans and unstable seafloor conditions are starting to melt those hydrate pockets. And fast. The release itself is dangerous for two big reasons. First, methane is a climate bomb. Over short time spans, it's more than 80 times more powerful than carbon dioxide at trapping heat. If enough of it escapes into the atmosphere, it could speed up global warming big time. Second, the process weakens the seafloor. As methane escapes, the sediment around it collapses. That can lead to underwater landslides. And in some cases, if it happens suddenly enough, those landslides can displace water and create tsunami-like waves. And it's not just theory. ROVs, underwater drones, have filmed massive plumes rising from fault lines and unstable sediment zones. In one area, the methane vents form long, winding cracks, almost like scars, running across the seabed. To make matters worse, all this gas release is messing with marine chemistry. It lowers oxygen levels in the water and increases acidity, both of which are bad news for fish, coral reefs, and basically everything that lives in the Gulf. Some scientists are calling this a warning sign that the entire region is destabilizing, geologically and chemically. It's all connected. Warming oceans, shifting fault lines, gas releases, seabed collapse. Right now, researchers are racing to map more of these vents and figure out how much methane is actually being released. But there's a growing sense that we might already be behind. The Gulf isn't just leaking gas. It might be leaking a warning we can't afford to ignore. Okay, this one sounds like something out of a sci-fi movie, but it's real. Off the coast of Galveston, Texas, deep below the waterline, researchers may have found the remains of an ancient, sunken civilization. In early 2025, a deep-sea mapping team ran sonar scans of the seafloor and picked up something strange. Massive, symmetrical stone formations buried under layers of sand and coral. We're talking shapes that look like straight walls, grid-like layouts, and flat platforms. Not the kind of thing nature usually builds on its own. It didn't take long for people to start asking the obvious question, did humans build this? The early signs point to yes. The layout of the structures looks intentional, too organized, too rectangular to be random. And when divers went down to check it out, they found something even stranger. Carved tools and pieces of pottery wedged into the cracks and coral. If this really is man-made, then it's old. Like, really old. Based on the sediment layers above the structures, scientists think it could be over 10,000 years old. That would place it before the last major sea level rise, during a time when large parts of the Gulf Coast were dry land. Back then, the shoreline stretched much farther out. What's underwater today might have once been fertile plains, rivers, and coastlines. It's entirely possible that early humans lived there and built settlements before rising seas swallowed it all. What's crazy is how little we know about that era. If confirmed, this would be one of the oldest underwater sites in North America and could completely change what we think we know about ancient human migration. Most textbooks still say early civilizations didn't start building complex structures until much later, but this site could tell a different story. Some scientists are even comparing it to the Yonaguni Monument in Japan or the sunken ruins off the coast of India, other mysterious sites that challenge our historical timelines. Now, researchers are using magnetometers and sub-bottom profilers, basically 3D underground scanners, to look for hidden chambers, roads, or even buildings beneath the sand. There's a real chance we've only uncovered the very top of something much bigger. For now, nobody's shouting Atlantis just yet, but the possibility is out there. If this find is what it appears to be, then Galveston might be sitting right next to one of the most important archaeological sites in the Western Hemisphere. The ocean doesn't give up its secrets easily, but sometimes it drops something too big to ignore. Not all disasters happen fast. Some creep in slowly, quietly, until one day, everything gives way. That's what scientists are starting to worry about in the waters off Houston. Here's the deal. The seafloor just offshore is sinking, and it's not just settling or shifting a little bit. We're talking about large, bowl-shaped depressions forming deep under the surface. Basically, giant sinkholes. And they're still growing. It started when satellite data showed subtle dips in the seafloor that hadn't been there before. Follow-up sonar scans confirmed it. Big, smooth indentations, some over 100 meters across. What's causing them? Turns out, it's ancient salt domes, massive underground formations left over from prehistoric seas. Over millions of years, layers of rock and sediment piled on top of them. And now, under all that pressure, those salt structures are dissolving. As the salt breaks down, it leaves behind empty spaces, hollow pockets. Eventually, the weight from above causes the sediment to collapse into those voids. That's how these sinkholes are forming. And that's a huge problem, especially in the Gulf. Why? Because that same area is packed with offshore oil rigs, underwater pipelines, and communication cables. Infrastructure that millions of people rely on every day. If one of those sinkholes expands too quickly, or worse, collapses suddenly, it could pull an entire rig or pipeline section down with it. That kind of failure could trigger oil spills, service outages, or worse. Core samples taken from the region show signs of heavy salt migration and disturbed layers, classic signs of active collapse zones. Some of the ground is literally softening underneath our feet. There's also concern about what happens if multiple sinkholes start linking up. A large enough collapse could even displace enough water to cause localized tsunami-like waves. It's rare, but not impossible. To keep an eye on the situation, scientists are deploying 3D seismic imaging, pressure sensors, and underwater drones to monitor how fast the seabed is changing. The goal is to catch signs of rapid movement before something major happens. But here's the thing. This process is natural, slow, and hard to predict. And the deeper the Gulf gets drilled and explored, the more we risk bumping into one of these weakened zones. The ground beneath Houston's waters is hollowing out. We don't know how far it'll go, but we know this. When the seafloor moves, it doesn't ask for permission. Here's something strange. Scientists have been picking up a low, constant hum coming from deep under the Gulf of Mexico. It's not a sound you or I can hear. It's just below the range of human hearing. But sensitive instruments on the seafloor have been recording it for over a year now. And no one knows exactly what it is. They're calling it the Gulf hum. It's not coming from ships, oil rigs, earthquakes, or even underwater animals. Researchers have ruled out all the usual suspects. This sound is something different, steady, low frequency, and unsettlingly consistent. Some seismologists think it might be caused by pressurized fluids, like gas or water, moving deep beneath the seafloor, slipping through rock layers and fault lines. As that pressurized liquid shifts around, it could be causing tiny movements that create vibration patterns we're now picking up with ocean bottom seismometers. Others believe it might be something bigger, slow, deep fault line activity. Not an earthquake exactly, but the early rumblings of one. In a few parts of the world, scientists have picked up similar low-frequency sounds in the months or years leading up to major undersea seismic events. And here's where it gets even weirder. The hum is moving. Slowly, over time, it's been creeping north along the continental slope toward the Texas coast. To figure out what's going on, scientists are now deploying deep-sea hydrophones and acoustic sensors all along the shelf. They're also feeding the data into supercomputers to simulate different possible causes: methane release, sediment collapse, fluid migration, even magma shifts. So far, no model has explained it perfectly. But what's clear is that something deep underground is moving, and it's creating just enough energy to make the whole region vibrate like a distant, constant bass note. And it's getting stronger. The Gulf hum hasn't caused any damage, yet. But scientists are watching it closely because it could be an early signal that larger geological changes are building up beneath the Gulf. If that's true, this isn't just a curiosity, it's a warning. The Earth doesn't always shake when something's coming. Sometimes it whispers. Every summer, the Gulf of Mexico holds its breath. Literally. That's when dead zones, areas with dangerously low oxygen, start showing up in the water. And lately, these zones aren't just showing up, they're taking over. In 2025, scientists recorded one of the largest and fastest growing dead zones ever seen along the Texas coastline. Stretching over 10,000 square kilometers, some of these oxygen-depleted patches are now creeping right up to shorelines and into bays, where people fish, boat, and swim. So what's causing it? It starts with runoff. Fertilizers from farms, wastewater from cities, chemicals from industry, all of it washes down rivers like the Mississippi and empties into the Gulf. Once there, all those nutrients feed huge blooms of algae. It might not look too bad at first, but when the algae die off, bacteria break it down, and in the process, they use up the oxygen in the water. The result? Massive stretches of ocean where fish, crabs, shrimp, basically everything that breathes, either dies or leaves. This used to be a seasonal problem. It'd show up for a few weeks in summer, mostly offshore, and then fade away. But now, it's lasting longer, spreading faster, and reaching places it never used to go. Fishermen along the Texas coast are already feeling the hit. Some shrimp boats are coming back almost empty. Oyster beds are being choked out. Popular fishing spots are turning into lifeless zones. And when fish can't breathe, the economy can't either. The Gulf seafood industry is worth billions of dollars, and these dead zones are punching a hole straight through it. Tourism takes a hit too. Nobody wants to swim or relax on beaches surrounded by dead marine life and murky, sour-smelling water. Climate change is making the problem worse. Warmer ocean temperatures speed up the algae growth and decomposition process. Stronger, more chaotic currents are now pushing these dead zones into new areas, including spots that used to be safe. Marine scientists are experimenting with fixes, planting vegetation buffers along rivers to filter runoff, even trying underwater oxygen injection systems in key habitats. But the truth is, these are just patches on a much bigger problem. Unless we deal with the root causes, farming practices, water pollution, and climate change, these zones will keep growing. And if we keep letting the ocean suffocate, sooner or later, it'll stop giving us what we need. This isn't just a warning, it's already happening. This might sound like science fiction, but it's real. Beneath the seafloor off the Texas coast, there are rivers of saltwater, massive underground flows of brine buried deep beneath the Gulf. These aren't small trickles, these are high-pressure rivers, some stretching for dozens of miles, and they're not leftovers from modern oceans. They're the ancient remains of long-gone seas, trapped underground millions of years ago. Over time, groundwater seeped into thick salt layers buried deep in the earth and dissolved them, creating these flowing channels of super salty brine. Now, here's the issue. Those rivers are slowly destroying the ground above them. As the brine flows through, it eats away at the surrounding rock and sediment. That erosion creates hollow pockets and weak zones in the layers above. Think of it like termites tunneling through the foundation of a house. It might look stable on the outside, but underneath, it's slowly falling apart. And this isn't just a weird geological fact, it's a real risk. If one of these hollowed out zones collapses, it could trigger a sinkhole, a fault slip, or even an underwater landslide. Some of those collapses could displace enough water to cause damaging waves or destroy structures sitting above them, like oil rigs or communication lines. What makes it riskier is that we don't fully know where all of these brine rivers are. Drilling through one accidentally, especially during offshore oil or gas operations, could release high-pressure, corrosive fluid into surrounding rock, causing blowouts or collapse events in seconds. That's why scientists are now pushing for better 3D imaging and subsurface mapping before any new drilling happens. They're using tools like seismic scanners and electromagnetic sensors to try and trace these rivers and identify unstable zones. But here's the catch. Mapping the Gulf seabed is like trying to see through layers of mud with a flashlight. It's slow, expensive, and easy to miss something. And as oil and gas exploration keeps expanding in the region, so does the chance that someone accidentally drills into one of these fragile zones. The ground under the Gulf isn't just soft. It's moving, hollowing out, and shifting in ways we're only starting to understand. These brine rivers are a reminder that sometimes the biggest threats are the ones we can't see. And if we keep poking around without a map, we might set off something we're not ready for. Imagine you're out on the water at night, somewhere off the Texas coast. Everything's calm, and then suddenly, the sea around your boat starts glowing. Soft blues, greens, even streaks of red, lighting up in every direction. It looks magical, but it might be a sign that something's wrong. These glowing zones, called bioluminescent blooms, have been showing up more and more along the Gulf. Fishermen have seen them, research crews have filmed them. They're beautiful, but they're also connected to something much deeper. What's causing the glow? Tiny microbes, many of them the kind that live way down on the seafloor, feeding on methane and sulfur. These extremophiles thrive in places most life can't. And when methane or other chemicals seep up through cracks in the ocean floor, these microbes swarm the area. Some of them glow when they're disturbed, especially when chemical levels spike. So when the water lights up like a scene from Avatar, it's probably because gas is leaking from the seabed. In fact, scientists have noticed that these glowing patches often appear near known fault lines, methane vents, and sediment cracks, places where the ocean floor is shifting or under stress. Some experts now think these bioluminescent blooms might be an early warning system, nature's way of flashing a light that says, something's changing down here. Underwater drones have filmed entire microbial mats carpeting the seafloor. These glowing mats can stretch the size of city blocks, feeding off hydrocarbons leaking through the sediment. That much microbial activity in one place usually means a big release of gas, sometimes even the kind that can lead to landslides or collapses. It's not just about glowing water. These microbial blooms could signal bigger things, like increasing methane seepage, growing instability in the seafloor, or even changes in ocean chemistry that affect everything from fish to coral reefs. Scientists are now collecting DNA from these microbes to understand how fast they're spreading, and whether their sudden rise is part of a larger shift happening in the Gulf's deep zones. It's tempting to see glowing waves and think, wow, that's cool. And it is. But it could also mean that the Gulf is becoming more active, more unstable, and more reactive to the changes we've triggered, whether from drilling, warming seas, or shifting fault lines. The ocean might be lighting up, but not just for show. It could be trying to tell us something. This might be the most unsettling part of the whole story. Scientists now believe the continental shelf off the Texas coast is becoming unstable, and if a big enough chunk collapses, it could send a massive wall of water straight toward cities like Galveston, Corpus Christi, even Houston. Let's break that down. The continental shelf is the shallow underwater ledge that extends out from the coastline before the ocean drops off into deeper water. It's like the Gulf's front porch. But right now, parts of it are building up pressure, sediment stacking too fast, methane gas seeping out, and the seafloor shifting more than usual. In other parts of the world, similar shelf collapses have triggered underwater landslides big enough to displace entire volumes of seawater. That's what causes a tsunami. Not just a wave, but a sudden, massive push of water moving fast and with force. Until recently, the idea of a Texas tsunami sounded like something out of a disaster movie. But with new data coming in, rising methane activity, spreading sinkholes, fracturing faults, geologists are starting to say the risk is no longer zero. It's now in the we should be paying attention zone. And then there's the other piece, ancient storms. Core samples pulled from deep below the Gulf seafloor have revealed signs of prehistoric hurricanes, storms so big they literally rearranged the coastline. We're talking wind speeds and storm surges that dwarf anything in the modern record. Scientists believe these storms happened thousands of years ago, when ocean temperatures were much warmer. Sound familiar? With climate change heating the Gulf every year, we're now seeing stronger, faster developing hurricanes than ever before. What if we're heading into another period where superstorms become the norm instead of the exception? Put it all together. Unstable seafloor, shifting pressure, ancient patterns returning, and it paints a clear picture. The Gulf isn't just changing, it might be resetting. Right now, researchers are using every tool they have, 3D imaging, pressure monitors, underwater sensors, to figure out where the biggest risks are. Emergency teams are updating models and plans just in case. But here's the bottom line. The Texas coast isn't as solid as we thought, and if one of these systems fails, if the shelf slips or a megastorm hits, it could change the entire shape of the Gulf and life along it in a matter of hours. The warnings are there. The data is piling up. The question is, are we ready to listen? So now you know, beneath the warm, familiar waves of the Texas coast, something massive is unfolding. From toxic algae blooms and spreading dead zones to methane leaks, glowing microbes, ancient ruins, and a seafloor that's literally cracking open. It's clear the Gulf isn't as calm as it looks. Some of these changes are slow, some are sudden, but they're all connected, and they're all pointing to one thing. The Gulf of Mexico is changing fast, and we're only just beginning to understand how deep that change really goes. This isn't just about science, it's about people, coastal communities, fisheries, industries, and ecosystems that depend on the Gulf staying stable and alive. If we ignore the signs, we risk being caught off guard, but if we pay attention, we might still have time to act. So whether you live near the coast or 1,000 miles away, this story matters, because what happens in the Gulf doesn't stay in the Gulf. Thanks for sticking with us through all 10 of these discoveries. If this blew your mind or made you think, share it, talk about it, and keep asking questions. That's how change starts. Until next time, stay curious, stay grounded, and keep your eyes on the water.